welcome everyone. My name is Carlotta A, and I'm a professor of electrical and computer engineering at Rose-Hulman Institute of Technology. And I am also the outreach lead for Black in Robotics. This is our second to last or almost last workshop for the year. We are actually going way longer in the season than we normally do. And that's based upon requests and demands, because I'm a busy professor, and once school starts, it's very, very difficult for me to hold workshops, which is why I've been on the Black in Robotics listserv trying to recruit people to take over outreach or help me with outreach and help me with social media. Because like I literally just got off a plane last night. I'm getting back on a plane on Wednesday. And in the midst of that, trying to get all this done has been more than a notion. So the mission of Black in Robotics is to, here's our schedule. We always put up a schedule. We don't never abide by it, but you need to always have learning objectives and a schedule. So here's at least where we're going to try to start. And it is going to be the introduction, the robot hardware, robot software, breakout room, a robot control, a little bit of lecture, but a whole lot of hands-on activities. Okay. So, but the challenge becomes because everyone is at different spots, it becomes very difficult to figure out where to put people, what breakout rooms to put you in, and things like that. So that's where the challenge happens. And so that's what's going on with that. Okay, so this is our goal for today, but we may or may not make it. So the mission of Black in Robotics is to thank you, Rachel. All my TAs, please help handle the chat for me, please, because when I get really swinging, I don't look at the chat. So it's to bring together Black researchers, industry professionals, and students in robotics to mutually support one another to help navigate academic, corporate, and entrepreneurial paths to success. Even if you don't fit any of those categories, we're happy you're here because we're trying to also get more people excited about STEM and robotics as well. To advocate for more diversity, equity, inclusion, and justice within the organizations that we live and work in, ensure that we have a seat at the table during the development, test, and deployment of robotics systems that affect our communities, and amplify our collective voices for calls for social justice. So in order to do that, our learning goals are today is to give a very brief definition of a robot. You should all have a robot in your hand or one on the way, or if you send me your shipping address, one will be shipped tomorrow. Define a basic robot control, electronics introduction, and then program robot behaviors, which is what I want the bulk of today to be about. All right, so what is a robot? If you've been to our workshops before, we always show the same graphic because we want everyone to start around the same point. A robot is simply a machine. It is simply a machine where you use software in order to get it to achieve some task or some mission, like vacuum a floor, pick up a dish, roll a ball, disarm a bomb, fly around, or whatever. Autonomous means how much human intervention does the robot need in order to do its task. Remote control means you drive it all the time. The human is always involved. Fully autonomous means the human doesn't have to do anything at all. Once you write the software, it just works. So a robot is going to have a body. Typically, the robot's body is designed based upon what the robot has to do. So if the robot's vacuuming on the floor, it's a little circle robot on the floor. If the robot is putting together car doors or painting cars at an automobile plant, it a lot of times looks like an arm or a manipulator because it needs to be able to move the tool around to spray the doors or pick up the car doors and move it. So the body of the robot is designed based upon the task that it has to do. A robot will have sensors, and you design the robot sensors based upon what the robot has to do. So if my robot has to detect colors, it'll have a color tracking sensor. If my robot has to detect objects, it'll have an infrared or sonar or laser sensor. If it has to follow a line, it has a different kind of infrared that detects black and white for following a line. Your robot today is going to have a sonar on it because a sonar, we use it to avoid obstacles. We can also put a photoresistor on a robot in order for it to track light. I will show you how to program the photoresistor, but one of my challenge questions for you afterwards is to show how you could make that robot track light. I'll give you some hints. I have YouTube videos about how to do it in Arduino. Your goal is to just make it work in Raspberry Pi Pico W. So the robot has some kind of task. You design it to meet that task. Then the robot needs to act on the world. Acting on the world could mean wheels touching the ground. It could mean the vacuum that sucks up the dirt. It could be the flippers or the propellers on a drone. It could be the flippers on a robot in the water. It acts on the world based upon the goal that you gave it. Okay, if you have any questions, please put them in the chat. We have 2 or 3 TAs in the chat who are here to help me answer your questions. Okay, so your robot is made of several things. We've had Arduino workshops, and that robot's brain was an Arduino. Today's workshop, your robot's brain is a Raspberry Pi Pico W. I'm also currently working on a microbit version of Lilybot for younger kids, where microbit is typically programmed graphically. So that means the same robot could then be used with Arduino, Raspberry Pi Pico W, eventually microbit, Raspberry Pi, or whatever. And then we talked about the robot's brain is based upon what you have to do with it. Your robot, I made open and circular with wheels because I want you to be able to see everything on the robot and understand how everything on the robot works and be able to drive it around and do something with it. The robot's effectors for your robot are wheels, because the wheels are the things that impact the floor as it moves around. The actuator for your robot are motors, because the motors spin the wheels to make the robot drive around. And like I said, the sensors you have, I think I gave you a sonar and a photoresistor are your sensors, but you also have a potentiometer for adjusting things like the LED, and you have switches. You either have a switch or a push button. I can't remember which one I put in the kit. Somebody can type in the chat and tell me. Switches and push buttons work the same. It's just a switch is a permanent one. A push button, you hold it down. But switches and push buttons, you program the same way. Thank you, Denise. It was a push button. Okay. So I think I gave everybody a push button, and I think I gave everybody the same thing. My students did some of the packing, so I'm not always sure of everything that's on your robot because they did it for me. Okay. The other thing on the top of your robot is robots need electronics in order to do stuff. So the sensors, the potentiometers, they have to have a way to talk to the controller and the robot. That breadboard is like your like a direction, the thing that directs the traffic, right? So you bring in data on the breadboard that then goes out to the Raspberry Pi Pico W, the microcontroller, or things from the microcontroller sometimes have to go through the breadboard and out to the motors on the wheels, etc. Your breadboard has connections. The connections are where things touch. So for example, if I wanted 2 things to touch on my breadboard, the yellow lines would be how they touch. So if I put one thing at the top left and one thing down here at the bottom left, they would touch. The blue and green mean that nothing on the blue row touches anything on the green row. I teach my students this, my engineering students, and they sometimes struggle with this because this is a visual understanding of what's going on here. Your breadboard looks a little bit different, but I will show you that in a minute. The way it got its names is also called a prototype board, but it actually used to look like a breadboard like this, and people would build circuits on it. And so the name breadboard just stuck. So your first circuit, which is the first one we're going to build today, is called your basic electric circuit is an LED circuit. We like to say it's the hello world of electronics. If you ever learn how to program anything, the first thing they tell you to do is to program hello world to print out to the screen. Or if you're doing electronics, is to blink an LED. So that's why I wanted your pre-work to be blinking the LED. So this is the first thing we're building today. So what I wanted you to do for your pre-work was to get the one blinking on the board. So one thing Denise observed is, unlike Arduino, when you plug in the Raspberry Pi Pico W, it literally shows nothing. Like there's no light that turns on or anything. So you don't even really know if it's working. You have to actually program that light to blink as your first starting point. Okay. So this is what you're going to do today. The battery part you don't have to do because the microcontroller power supplies the battery, but you're going to put an LED on a breadboard, put a resistor on a breadboard, connect it to the microcontroller, and we're going to make it blink. So it's going to be very similar to what you just did for the pre-work, or for those who are going to do it for the pre-work when I put you in the breakout rooms. The front of the Lilybot is where the words Lilybot are. So Dave, this is for you. Dave sent me a picture of his Lilybot and said there's something wrong because it was all skewed. So Dave, notice about the screws here. When your module is in there correctly, Dave, there should be some screws here that hold it in place. It does go a little bit over the words, Lilybot, but there should still be enough space over here on this side so that you can actually put a sensor here. LED tip, make sure your anode, the longer leg, is going to positive. Not putting a, hold on, a semicolon on your hello world code. Yes. So you're exactly right. In fact, what we tell people is that if your LED don't light up, then you need to flip it. You got it in backwards. So the other thing is you should have a Raspberry Pi Pico W. Some people have male headers. Some people have female headers. It kind of depended on just what you had when we built it, but it should look like this. Since the Lilybot is the front of the robot, the left wheel is here. The right wheel is here. Any resistor less than 300 ohms is fine. So I'm going to put some colors in here. Brown, black, red. Because it also depends what we put in your kit. Brown, black, brown, sorry. Some people got red, brown. That's 220 ohms. Some people got orange, brown. That's 330 ohms. So anything in the 300 ohm window, make sure it ends with a brown. As long as it ends with a brown, you should be okay. So looking at the colors, that last color is probably silver. And that just tells you the tolerance. Don't worry about that. So all the colors before that is what you want to look at. Some color, brown, and that should be fine. Okay. That was Kaya's question about what size resistor to use, and anything in the 100, 200, or 300 ohms. All right. You should have a programming cable. Yours may be pink, green, yellow, or some other color. There is a battery pack at the bottom. It's going to require 4 AA batteries, but you don't need the batteries today because everything we're doing today, the robot's plugged in anyway. At the end, you will need the sonar sensor for obstacle avoidance. We talked about the Raspberry Pi Pico W. Here's the breadboard. There's a motor controller that came mounted on it already. You'll need that for the end, and then there's just a lot of wires. Okay? Is everybody doing okay?
Yes.
Very good. So levels of robot control, I told you already, remote control, semi-autonomous, fully autonomous. So we're going to be working somewhere around here today until we get to obstacle avoidance. And then after we write the obstacle avoidance code, it's fully autonomous because it then just avoids obstacles. So these are what you call your robot control primitives. They're not always connected like this, but you don't need to worry about that. But basically, you have to sense about your environment with the sonar, the photoresistor, whatever. Make a plan for what needs to happen. In your case, your robot's going to run away. And then the robot acts by driving away or driving towards the light or driving away from obstacles or whatever. Are there any questions? Okay. Your Raspberry Pi Pico has 42 pins. We are primarily going to be working on the right side of this board. Everything we need for today is on the right side of the board. We have the bus voltage from the USB. We have the system voltage, which is 5 volts. We have ground. We'll use the ground today. We have a 3.3 volt, which we use for the sonar because the sonar is a 3.3 volt sensor. And then everything else is general purpose I/O. And that's where we connect like our LEDs, the potentiometers, the switches, the motors from the motor driver, etc. So whenever I say we need to put something on pin 16, that would be the pink 16, or put something on pin 28, that would be the pink 28, not these black numbers. Those are just numbering the pins in general. But that would be where like this pin 28, like I think we're going to put our LED right now on pin 28, which is 1, 2, 3, 4, 5, 6, 7 from the top on the right. All right, I'm ready to start building. So everybody get out a LED, get out a resistor, and I'm going to help you build your first circuit. I'm going to go through the first 2 of these, and then we're going to do breakout rooms. And after we get everybody LEDs working, we'll come back. Okay, so what you're making is long leg, like Shioma said, long leg goes to a row on your breadboard. And that wire from that long leg goes to pin 28. long leg on one row of your breadboard. A wire from that same row goes to pin 28. Short leg goes to another row on your breadboard, and then that goes to a resistor. I have a 220 ohm resistor here because it's red, red, brown. Yours doesn't have to be 220 ohms. Yours could be brown, black brown. It could be brown, some other color brown. Just make sure it's a brown before the gold or silver part. Okay. Then the other side of that row is going to ground, which is 3 from the bottom. I need you to put in the chat, got it, when you got your LED connected. You're basically matching this picture where the cord of your cable is up here, coming out this left side here. So that means 3 from the bottom on the right is ground, and 1, 2, 3, 4, 5, 6, 7 from the top on the right is 28. I see some thumbs up. I think that means everyone's doing okay. There may be like 4 or 5 resistors in your kit. Thanks, Rachel. There may be 4 or 5 resistors in your kit, but only one of them is not in the hundreds. There's only one resistor in your kit that's not in the hundreds. So probably every resistor you pull out ends with something brown other than one. Long leg goes to 28. Short leg goes to the resistor. I think that's what Coyote is saying. Yes. Long leg goes to GP28. Short leg goes to the resistor that then goes to ground. Thank you, Elsie and Ted. Elsie and Ted are good. Okay. So you're essentially matching the picture. Julia's good. Dave's good. Okay. I'm going to play a short video first so you can see what it should look like when it works. Then I'm going to talk you through the code. And then I think I'm going to be ready for the first breakout, because until we get everybody blinking LEDs working, it's kind of hard to do anything else. Oh, no. Thank you, Shioma. Okay, Shioma's just watching. And I'm going to also post a video on YouTube at some point. Okay. All right. I'm about to play the video, but if anybody needs me to hold up, put hold up in the chat. Okay.
All right, progress is slow, but we finally got our blink working on pin 28. I think the challenge I'm having is on the Arduino, the internal LED also has an external pin. It's pin 13. So when I kept reading that pin 25 was the pin on the Raspberry Pi Pico, I kept trying to blink pin 25 and I could not find pin 25 anywhere, so I couldn't blink the LED. No clue what's going on with that, but after changing the pin 28, I did get it working, so take a look. Remember, it's these small things that make us so excited. So the regular LED is not blinking anymore, but the blue LED on pin 28 is. Woohoo! Let's keep it going. Now I have my first digital output working. Now I need to get an input working.
So that's a digital output. So digital, remember, means constant, not changing by real numbers. So digital means just on or off, ones or zeros, like a light switch. So let's walk through the code. All right. I'm going to put the code in the chat, and then we're going to have everyone go into a breakout room. Thank you so much, Dave, for coming. Thanks for coming. Okay, so what you're going to have to do, and everyone who has the internal working, this should look familiar, is you're going to import your libraries to run MicroPython, your machine, and your UTime library. Then you're going to define the LED to be an output on pin 28. Then I just always print some kind of debugging message at the beginning that lets me know the code is running. Then we're going to define the delay to be half a second. Then in the run indefinitely and fun indefinitely, because that's a typo, that you're going to turn the LED on. I will show you how to get to that screen, Julia. And you're going to wait half a second, turn the LED off. Okay. So in Visual Studio, isn't it? Yes, it's Visual Studio Code. Yes. But we're running Python inside of here. Yeah, so you're right. Visual Studio Code, but we're running Python inside of here. That's Platform IO. So after I got the Raspberry Pi Pico W configured to work with MicroPython, I went in here and I installed the MicroPico extension. I installed the MicroPico extension, and then I created my first file and I configured it to be a MicroPico project. And external LED is the one I just went over with you. So then I type this code in here, and then I right click and I run the current file on the Pico. So what we're trying to do right now is get everyone to get this working. What you were going to do for your pre-work is the exact same thing, except now you were going to be flashing the LED that is internally to the Pico W. So when you go into the breakout rooms, and I'm going to put all of the Mac people together, your goals are to get the internal and external LEDs blinking. And then when you come back, we move on to our next challenge. Is everybody clear on what you're doing in the breakout rooms?
Are you seeing?
I can see it.
Yeah, so I just copied it into here and I'm running it.
Oh, I see. We got to do some magic here. Okay. So what you're going to do is where you took the stuff I put in the chat, because you put it right up under the other stuff. Oh, I see what's wrong. I can fix this for you, Mama. Got you. Okay. So what you're going to do is where you see my stuff that says CAB, blah, blah, blah.
Yeah.
I want you to start.
Oh, this got imported twice.
That's exactly right. You got to delete that. Delete that chunk you just highlighted.
Okay.
And now I want you to copy and paste, copy everything underneath up to the top. Everything, from there down, copy.
Oh, copy 19 through 32.
Yep. Because we can run both at the same time, but you're doing the same code twice. It doesn't like that. So we'll actually stop.
Where do I paste?
Okay, stop. Don't paste yet. This is what I'm gonna have you do. Okay. Unhighlight. I changed my mind.
Okay.
So you're gonna do some. Do you see where it says LED equals machine.pin 28?
Yeah.
Highlight and cut that. So highlight that line and cut it.
Just delete it.
Nope, you're gonna cut it. You don't want to delete it.
Okay.
You're moving it.
Sure.
You're moving it.
Okay.
Now go scroll up. Scroll up, 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 up. Paste it right under where it says pin equals pin. Paste it right there. That's exactly right. Okay. Now, you got to change your code. No, scroll back up again. Cheryl got the hot fingers. Okay. Do you see where you see the squiggly machine? It says squiggly machine, squiggly machine.
Yeah.
Squigglies mean the code is not happy.
Oh.
So what you're going to do is delete the word machine.
Okay.
So because you merged your code together, you got two different things going on, and so it don't understand. So delete that one as well. Delete the word machine.
Okay.
Okay. Very good. Now scroll back down. And define the LED output. Delete print message.
Okay.
Delete print LED flash 2.
Okay.
Okay. And delete define variable for half a second. Delete all of it. Yeah. Delete delay 0.5.
Okay.
Delete fun indefinitely.
Oh, just delete all the rest of the lines?
No, not everything.
Oh, okay.
Delete fun and delete while true. Okay. Delete while true. Just that. So now what happened? What happened was you had an infinite loop running and it never was getting down to the rest of your code.
I see. Yeah.
So now what we've done is we're merging the two together. Okay. So now, but we need to now fix the fact that it does not know what U time is. So you're going to delete U time. See anything red squiggly, it's not happy with us. Delete and delete U time at the bottom. And it also does not know what delay is. So instead of delay, you are going to change it to a 1 so that it just waits 1 second like the rest of it does.
Okay.
Okay, make that one a 1. Okay. I think we are ready. I want you to run this and see what happens. Right click. Yep. What happened?
Oh wait, let me stop it. Okay, now
Is everything is in test app? Okay, yeah, run current file on Pico.
it's still not working.
No, come on now. It's gotta be. Basically, what this code is saying, pin 25 and pin 28 should both be blinking.
Yeah.
LED dot value 1, LED dot value 0. Yes.
Yes, please.
Okay. Okay. So next, you're going to control the LED with either a switch or a push button. So because I couldn't remember which one I sent you all, I put them both up here. Like I said, whether you have a push button or a switch, the code is essentially the same. And now you're going to have a digital input. The LED is a digital output. The push button will be a digital input. And you have to use 2 wires for either the switch or the button. So one of them will go to ground, and the other one will go to pin, I don't remember the pin number. I think it is 26, but let's look and make sure. It will go to pin 26. So Kaya said he found some code to blink the LEDs and modified it a little. I believe this is the same code I just pasted, but thanks, Kaya. So you can take a look at that code for those of you who are still working. So on pin 26, that's where you're going to put the button. All right, so that means this blue wire is going to 26, whether you have a switch or a button. And then I will show you it working. And after that, I will show you the code.
Hello, party people in the place to be. We are continuing with our journey to get the Raspberry Pi Pico W working on the LilyBot with MicroPython. So we now have our working digital input, which is a push button. So let's review the code and then let's take and see what it does on the robot. Okay, so here we have our code. From machine we import pin, from time we import sleep. Then we have the LED pin on pin 28. We have the button pin on pin 26. Then for the LED pin, we declare it to be an output. For the button pin, we declare it to be an input with a pull down resistor. And then we have a delay of 0.5. So to start the code, we print button control of LED, and then while it's true, we print out the button value. And if the button value is positive or true or 1, as opposed to 0, it's going to toggle the LED. So now I'm going to come down here and click run for the code. So you see it is printing zeros. So if I press the button, it now prints ones. And let's see what this looks like on the robot. So here we have the robot, and I have 2 buttons, but ignore that other one. Here's the LED, the resistor, and here's the button. So if I hold the button down, the LED toggles or blinks. If I let it go, it stays either on or off. So it stayed on, but I can also make it stay off. If I hold it down, it toggles. Please come back for more.
Okay, so I know it was kind of hard to see, so I'm going to show
place.
you the code again. It's still in platform IO because I didn't have time to move it over. But once again, you're going to have a LED on pin 28, so the exact same place where it was before. You're going to put a button on pin 26, or like I said, you could put a switch on pin 26. Then you make the LED pin an output like you had before. You're going to make the button pin an input. And then you're going to run this code. So based upon what I just saw with Cheryl, I want you to make a brand new program. Any code I give you, make a brand new program. Don't merge because the code is going to conflict. So notice every time I did something, I made a brand new program. So I have a button LED program. I have an external LED program. I have an internal LED program. So make a brand new .py file. You can put it in the same folder, but make a new one. So I'm about to paste this in the chat.
Our button only has 2 leads instead of the 4, like the one in your diagram.
Uh-oh.
Trying to think how it's got.
So is that Ted who's talking?
Yeah.
Okay. So Ted, the 2 that you have, are they on the same side?
They're both in the middle. Like, I don't know if you can see that or not.
Does it look like this over here, or it doesn't look like that either?
It does. It's a push button for sure, but it only has 2 leads instead of 4.
Can you hold up your can you hold it up to the camera and let me see? I'm wondering if your pins broke off. That's what I'm trying to think. That's what I'm saying.
I think it's okay.
If they're on the same side, you're okay. If they're not on the same side, yeah, I need to see something.
Yeah, I got that as well. I think you can just use it like that and not use the top 2 pins, and you're fine.
Mine is the same as theirs too. It has like just the 2 pin. It looks the exact same as theirs.
Yeah,
so
I have it as well.
If they're 2 and it's on the same side, then you can do this and just ignore it. Because if you notice, I don't even have this connected. So if it has 2, you just use the 2 that you have, where one of them now goes to 20, and it doesn't even matter which. Just one wire goes to 28, that's GP 28, and the other goes to a ground, right? So if you notice, we're going to count from the top right.
So is this a separate circuit than the other one, right? This is just telling the board when it's supposed to do its commands to the other circuit.
Correct. So
okay.
So your LED that you had, keep it. Wherever it is, keep it. Nothing changes. You're just now adding the 2 pin onto the same breadboard, and everything else you can ignore, but you're now going to have one wire that goes to ground and one wire goes to pin GP 28.
Cool. Thank you.
Okay. And then the code I just put in the chat, you're trying to see if you can push a button and make yours blink. I don't remember that you guys got a different button, but yeah, that should be fine as long as there's 2 pins and one can go to 28 and one can go to ground. Okay. Other questions? All right, I'm going to keep going because I want to show you a little bit more before we do the breakout. So next is going to be all of these concepts I teach you with the LED, you can extend to the robot, but they help you to understand what's coming next. So far we have done digital input, digital output, and now we're going to do an analog input. So remember, digital means on or off, 1 or 0. Analog means it can take on any value along a continuous number line. An example of an analog input is a potentiometer. Potentiometer just means variable resistor, variable resistor. That means it can take on any value between 0 and 5 volts based upon me turning this knob. So it looks a little different in my video because I have to get these from a website, but in your, actually, I don't know if you guys have the potentiometer. Sorry, I'm gonna skip that one because that's just gonna confuse you. I forgot, I didn't put that in there. I put a different one in there for you. You're gonna do the photoresistor. So in your kit is a photoresistor. You should have this. Now, remember, I told you there's one resistor in your kit that is a different size than all the rest. That one resistor is 10 kiloohms. The 10 kiloohm resistor will not light up your LED. If it's in series with the LED is not going to turn on. So Cheryl, you want to make sure this resistor is not touching the LED. The photoresistor detects light. So what happens is that if you have the photoresistor you have to put it in series with a 10 kilo ohm resistor. So this resistor should be in your kit, and it should be brown, black, orange. Brown, black, orange. It is the only one that ends in orange. Everything else in your kit ends in brown. So everybody put in the chat and tell me if you're able to find the 10 kilo ohm resistor. That's an ohm meter, Kaya. So that's good. So the photoresistor amount is a rectangle. That rectangle.
So hey, welcome back for another
update. Rectangle has a photoresistor on it. And then there's a 10 kilo ohm resistor in your kit. So everyone try to find the photoresistor and the 10 kilo ohm resistor. The 10 kilo ohm resistor is brown, black, orange. And then there's a photoresistor. Can everyone see my slides okay?
Yes, we can see your slide.
Okay, nobody's answering me.
Yes,
Okay, so
we can see it.
okay, so see if you can find your photoresistor and the 10 kilo ohm resistor. And when you find them, put yes in the chat. Like I said, the photoresistor should be mounted to a rectangle. And then the resistor is going to have brown, black, orange on it. Okay, I'm seeing some yeses. Okay, so what you do is one leg of the photoresistor goes to the 5 volts. One leg of the photoresistor goes to the 5 volts. So since you can attach yours directly to your robot, what happens is you take a wire, it's called a male-female wire. A male-female wire means that one end, and Kaya is the only person who has a different robot. So Kaya's wire is going to be a male-male wire, but everybody else should be male-female. So you're going to take a male-female wire so that you can connect one leg of the photoresistor to the 5 volts. That's the top right pin. And then connect the other leg down into your breadboard, like I have here. Then the brown, black, orange resistor goes between 2 different rows, like I have here. And the row where the photoresistor is, that goes to pin, let me go look. '27, and the LED is still on pin 28. 27 and 28. Okay, and now I'm going back to my slide, so let me know if you can't see the slides. Okay, and then that other part goes to ground. So I want to show you what this looks like. This is a light detecting photoresistor. After this, you can see the slides. Okay, thank you. After this, we're going to go back into the breakout room to keep working, to try to get everyone to have a working robot before we end the workshop. So your goal is to keep working towards this goal. Even if you don't get there, you're trying to get here. Okay, so here's what the photoresistor controlling the LED looks like.
This is my second to last subsystem test before we start integrating the system to make the full robot, autonomous robot. So this is the photoresistor, which is a light sensor. The resistance changes based upon the light. And we're using the photoresistor to change the blink rate and dimming and brightening on our LED. So check it out. So here we have our robot that is blinking based upon the ambient lighting in the room. And we have the photoresistor here, 2 resistors, and the LED. So what you should see is that as I cover it, the blink rate changes and it gets more dim. But then if I take bring the light back, the LED gets back bright, right? So that's what it's doing. It's adjusting the LED based upon the amount of light being detected by the photoresistor. So the more I block out, the dimmer it gets. So what does this look like in the code? First down here, we are printing out the data. So as I cover the photoresistor, you see that the numbers get smaller. As I take it away, it gets brighter. Then if you go through the code, I import from machine, pin, ADC, and PWM. I import from time, sleep, and microseconds. The photoresistor is on pin 27, the LED is on pin 28. I initialize the photoresistor as an analog to digital converter pin, the LED as an input output pin. I set the frequency to 100 Hertz. I have the in max and min values, the out max and min values, so that after I read the photoresistor, I can scale it to the range I want. I print the data out and I write it to the LED. So I hope you enjoyed, and please come back for more. Stay STEMtastic.
Okay, I want to show you guys something. Oh, based upon what Kaya just said. So hold on. What I was saying is that this is a sonar mount. Okay, this is what you use to attach the sonar to your robot. I don't think I have one with me, but you guys have another one of these that's a rectangle. The rectangle is what holds your photoresistor. So you put this in the robot by dropping it in this hole here, and then you turn it, right? You turn it so that it attaches to the robot. So for your photoresistor, you do the exact same thing. And now those legs that stick out the back, you use the wires on those to connect it to either your breadboard or your microcontroller. So that's why the photoresistor is attached to that bracket, Kaya. It's so that you can attach it to your robot like this. Are there questions about that? Questions?
Okay, so Dr. Berry, do we have all these codes in any of your GitHub repo?
It is in the GitHub, and it's also on Instructables, and it's also on Hackster.io. So
Okay.
if you go to yay,
Yeah, Denise,
her LED blinking, yay! We take our celebrations where we can get them. Yes, Cyril, let me put the GitHub in the chat. I actually don't have the GitHub in the chat, but I will put it in there. But there is yes.
You can copy the entire repository. That's what I did. I just copied and pasted the entire repository into VS Code.
Really? So you know,
Yeah.
you know more about VS Code than I do. Now, some of that stuff you probably don't care about though, because like it's got CAD
Yeah,
files.
there's flower bots and stuff, but like it's whatever.
It's whatever.
Just download the Flowerbot.
Yeah.
And maybe
All right. Somebody needs to show me how to
folder.
put a repo inside VS Code because I don't know nothing about that. So that GitHub has the Arduino code and it has Raspberry Pi Pico W code.
Yeah, you can just delete that if you don't want it.
Okay, thank you. All right, so I put the GitHub in there because y'all teaching me stuff I didn't know today. So the whole GitHub is right there. I just put the link in there for you. GitHub is not my ministry. Okay.
If you want to download the repository, here's the link to download.
Thank you. Are you putting that in the chat as well? Who's talking right now? I don't know who's talking.
Ari.
Ari, did you put that in the chat as well?
Here we go.
Thanks, Ari. Okay. Ari's a champ. All right. So does it sound like everybody in the Mac room at least now has the internal LED working?
I don't, but this is Rachel. I'm still working on just getting the software. And I think when I go to the office, where I have a PC, I'll probably play with it during the week.
Yeah. And the Mac should work because the person who I watched to learn this stuff was a Mac person. I just converted it to Windows when I started doing it. But I know the Mac works because the guy who I was watching was Mac.
The other thing we talked about was that I'm using an external hub. So I need to unplug from my USB, even though Ari told us how to circumvent it. It's probably easier for me just to, once we're finished here, unplug what I have and then plug into my USB.
Okay. All right. I want to take the last 8 minutes and walk you through what you need to do on your robot really quickly, and then we'll wrap up. So if there's any questions, please put them in the chat. And I'm going to really quickly walk you through what has to happen next. So just be patient with me for a second. I'm going to speed through a couple of these slides. The slides will be available online. I will fix that schematic that's wrong when we get off today. All of these things are available on Instructables, Hackster.io, as well as the GitHub. Okay. But I want to at least talk you through the stuff you need to get the robot working. Okay. So after you get the LEDs and all that working, the next step is to now use your analog input as a sonar. The sonar is going to be connected so that you now illuminate your LED based upon the value that it's reading from a distance. Can everyone see my slides?
No, I still see your code.
Oh, good Lord. Oh, it's one of those days, Ted. It's one of those days. Okay, hold on. All right. So what you're going to do is can you see my slides now?
Yes, please.
Yes.
Okay. So you're now going to wire the sonar. The sonar is already mounted. You just have to connect it to the robot, like in my picture. And you're going to use it to illuminate the LED. So the LED is basically our test point that we're using to make sure everything works. So here's what this looks like on the robot.
So hey Saints and lovers of STEM, I'm back for day whatever. I can't even remember what. So the video you are about to see, you're going to see the sonar reading distance in MicroPython using the Raspberry Pi Pico W. And then as I get closer and further away from the sonar, the LED gets lighter and darker. So take a look. Here's a brief overview of the values I get
for now because
main loop. All right, let's take a look. The LED turns off. So here's my robot with a super bright LED. And so then if I use this book and the book starts coming in closer, you can see the LED turns off. As the book moves away, it gets brighter. It's kind of hard to see because this is in the way. I'm trying to move some of these wires down. Okay, so no book. Bright. Dark. Further away. Bright again. So the sonar is working and the LED is working. Next, we will work on the buzzer. So hi, Saints and lovers.
Buzzer because you don't necessarily need the buzzer to make the robot work. Okay, so now after that, what you're going to do is you are going to connect your two motors to the motor driver. This blue driver that's already on your breadboard is your motor driver. There's a lot of wires that's got to be connected for this, so I would walk through the Hackster IO where I explain that. But you're going to put the left and right motor on the motor driver, and now this is what it looks like when it runs.
Forward stop. This looks like, all right, forward and reverse. Our next task is to get obstacle avoidance working and then write up the instructions, and we are ready for the October 15th Black In Robotics workshop. I can start shipping out the robots.
All right, so this now you're going to have an analog output that basically makes the motor spin forward and backwards, okay? So that'll be your next task. The very last task is now to integrate the motors with the sonar, So now what happens is that as you read the sonar data, it is going to, wait a minute, this is the wrong video. Sorry about that. As you read the sonar data, it's now going to avoid obstacles. So hold on one second. I need to get the right video in there. For some reason, that was the wrong one. 1 second. And this is your last step. And this is where we're going to end the workshop. But I do want you to see it working. So give me 1 second. Don't know why it put in the wrong video. Let me know if you cannot see my slides anymore, okay? Let me open up the chat because I don't know what you guys see right now. Okay, Kaya, that's fine. Everybody's a bit behind. That's why I'm giving you all these things and making videos so that whenever you get there, you can come back in and revisit this workshop to get where you need to get. All right, so now this is what happens is you now have the sonar connected. You have the motors connected. You don't necessarily need the LED. I'm using the LED to determine when it sees an obstacle, so the light turns on. So that's a test point to know if it's working. Also, I didn't have the right mount, so that's why my sonar looks like this. Your sonar should fit directly on your top of your robot. So now, after you wire it up, you will have the motors wired, the LED wired, the sonar wired, and this is what it should look like when it's avoiding obstacles. Mine has batteries, so it's not tethered to my computer. If you don't have batteries yet, it should still work. It's just that cable is going to be attached to the Pico W. what should happen is the robot is trying to move forward.
All right, we got liftoff.
Unless it has
We got a working design.
okay. So all these videos are going to be on YouTube. The code explanation. When I get some time, I will put up more videos as well. Not sure when time happens. Yay, Denise is getting there, cooking with gas. But remember, I will have all these resources available for you. They're not going anywhere. And I do periodically put up more when I get time. And then you can always email me if there's something that you want, that you need, that is not there. But Rachel, I can make pictures of the wiring and send that out to the group. Okay. I just have to rewire my robot. It's just my robot has been stripped and taken apart. Rachel, what part do you want pictures of? Like, is there a certain circuit or all the circuits?
I wanted to see the final circuitry to make sure I have everything in the right spot.
Okay.
Yeah.
All right. I will send
Dr.
you
Berry.
of the final circuit. Yes, somebody else had a question.
Yes, it's Ted and Elsie again.
Yeah.
I was looking through your where you have all the code on GitHub, and the button code there says to connect the button between 3.3 volts and pin 26, which is a different pin than either of the ones we were looking at. And when I connected that, it does work.
Does that make sense?
I mean,
3.3. Okay. I must have changed this at some point and I didn't change the instructions. Thanks for that. I'll fix it. I'm going to build it today, figure out what is going on, and I'll redo that and put it online for you guys. Thanks for helping me out, Ted. I'm sorry. I must have changed it at some point. Somebody else had a comment?
Yeah, how do I attach the sonar thingy? The sonar thingy.
The sonar? So
Oh, the
I'm going to go
sonar.
back. So for the sonar, you are going to have 1, 2, 3, 4 wires.
Yeah, I have the wires attached. How do I attach it to the actual robot?
Oh, okay. Hold on.
Yeah, how do I mount it? My bad.
Can you see me right now?
Yeah, I see you. Yeah.
Okay. So this came with the robot, right?
Yep.
You have one of these.
Mhm.
The sonar
Yeah.
needs to be in here, but it's going to be in here upside down, right? So it's going to be in here like this. Yes. This is the wrong size, but you see that?
Yeah.
Now, this is like a key. So you drop it down in this slot here, and then you turn it.
Okay.
Did that work?
It's I'm trying to do that, but it's like really there's a lot of friction there.
Like it's really hard to turn, you mean?
Yes.
It shouldn't break. If it does, tell me and I'll ship you another one. Did it turn at all?
It's turning, but like it's diagonal. It's like slanted.
Can you turn harder?
I'm turning harder, but I'm afraid it's gonna break.
yeah, we had to turn really hard and we just got it in, so it is doable.
Oh, there we go. Never mind. I got it.
Yeah, we did that on purpose because we don't want it flopping around. Like this one kind of kind of floppy because this was before we changed it. If it breaks,
Yep.
email me and I'll ship you another one. Okay.
All right. I got it in though. So.
Okay, so now those 4 wires are going to come up out of the top and go down into the breadboard or down into the microcontroller. So, okay, so to wrap up, everything you should need, I'm going to put the resources in the chat again. That's the GitHub, the YouTube, the Instructables, the Hackster.io. I think that's everything you need. Okay, so I want to thank you for coming. Your job is to get all of my projects working, which I will have all those links in the chat for you in a second. And then after you master that, it's to take the things I sent you to try to do something I did not show you how to do. For example, can you make the photoresistor do light tracking? I have videos of that working with the Arduino, but I haven't had time to do it for the Raspberry Pico. Can you make the robot play music and lights and dance at the same time? I don't have a video of that, but it's definitely doable. Instead of obstacle avoidance, you can do object tracking, which means now when it detects an object, it's trying to maintain the distance from it. So now as you draw away, the robot speeds up and slows down. I do have some Arduino videos of that kind of working. The wireless control, the Pico has the ability to be wirelessly controlled. I didn't have time to do that at all. Your job is to do some of these things, share it with us, and let me share it on social media to show people how cool our workshops are. So share your success stories with me via email, or you can just put them on social media and tag Black In Robotics or tag me at Noir Stiminus. You can also join the Black In Robotics community. Thank you for whoever pasted that for me. The GitHub is in there somewhere too. There is one more workshop before the end of the year, and then we'll start back next June with whatever workshops we start back next June with. I'm going to send you out a survey at some point, but I want you all to get some things working before you do the survey so that you can actually answer questions about what went well, what didn't go well, etc. So I'm going to put a reminder to myself, probably November 1st, which is about 2 weeks from now, to send out a survey where I'll ask you questions about the robot, about the software, about the workshop, and etc. That also will give you time to go through and watch the videos and things again in order to do that. So I'm wrapping up now, but if you have any questions, I'm willing to stay on for about 15 or 20 minutes or so to answer your questions.